Greetings, mathematicians! In this video, we are going to focus on the learning target related to estimation. But first, let's start with a quick warm-up. Go ahead and pause the video, give this question a try, and then come back to check your work. All right, let's see how you did. Remember that it's often helpful to start by taking anything that is not already written as a decimal and start by writing it that way. So take the square root of 5 and rewrite it as approximately 2.2. Remember, that's your rational, so you might need more decimals than that possibly, but we'll start with this much. And negative root 3 is approximately negative 1.7. So out of all of these values, we have two that are negative. Negative 1.7-ish is smaller than negative 1.09-ish. So that's how I know that negative root 3 comes first, then negative 1.09. Then move over to our positive values, and 2.2-ish is our largest. That's how I know the root 5 would be last. 0.04 is smaller than 0.1. That gives us the order of these two values. So moving on here, here's our essential question for today. We're going to be looking at word problems and real life problems, and we want to know how we can estimate to solve them. Now in this section, one thing that's going to be a challenge is that we might get different answers from each other, because when we estimate, that's different than getting an exact answer. So what that means is we're going to try to get something that is reasonable, or something that's close or good enough to the actual answer. It lets us do math quickly, so maybe you take $11 and change it to $10, because 10 is a nice easy number to work with. It lets you do math in your head when you don't have a calculator handy. A lot of the work that you've seen here we might have talked about before, but maybe we didn't talk about it so explicitly. So you've seen us use an equal sign, and you've seen us use kind of like these squiggly symbols before. So those squiggly symbols, that is the approximation sign, and we use that when we're estimating. So we actually just did that in the warm-up a moment ago, where we were looking at, for example, the square root of 5, and we used the approximation symbol to say that it wasn't exactly 2.2, but we were rounding off a little bit. So what we'll be doing here is we'll be using that symbol to show that our answer is not exact, but hopefully it's close enough to give an idea of what the approximate answer would be. So let's look at a couple of problems. So here's our first scenario. We're going to buy 3 candy bars that are 95 cents each, and we're going to buy a soda that is $1.99, and we have a $5 bill to pay for this stuff. And we want to know, do we have enough money to purchase this? And we want to try to use estimation to solve. So what we'll do here is we're going to say that these candy bars, instead of costing 95 cents each, we're going to estimate that to be approximately $1 each. So we're rounding 95 cents to the closest dollar. 95 cents is pretty close to $1. Same thing with $1.99 for the soda. That's really close to $2. So we're getting 3 candy bars for about $1 each. And we're getting 1 soda for $2 each. And that's a total of about $5. So we should be fine. The $3 plus the $2 gives us $5 total, and that was with us rounding up. 95 cents rounding up to $1, $1.99 rounding up to $2. So we should have enough money here, and we're talking about food, which is typically not taxed in our area. So we should be good to go here. Here's the next example. So we have Hector, and his hometown is approximately 59 square miles, and the population of his town is about 35,097 people. And we want to find out about the average number of people per square mile in his town. So, people per square mile. So we're doing people per means divide by square miles. So we're going to estimate the number of people, we're going to estimate the square mileage, and we're going to divide those. So number of people, 35,097. Oh, that's about 35,000. 59 square miles, that's pretty close to 60 square miles. And then if we simplify this, use your calculator, that's 583.3 repeating people per square mile. And if this were a free response question, that would be fine. We could leave our answer like this. Since this is multiple choice, we're going to pick the value that's closest to this. Our answer here is between 500 and 600, and 583.3 repeating is closer to 600 than it is to 500. All right, and here's our last example for today. So here we have Casey. She is buying 5 1/3 yards of fabric for $21.67. And we want to approximate the cost per yard. So cost per yard. Remember, per means divide. So we want the cost is $21.67. Well, that's pretty close to $22. And the yards, that is 5 1/3. That's pretty close to 5 yards. So we're doing 22 divided by 5. So that's about $4.4 per yard, or $4.40 per yard. And again, if this were a free response question, we could leave our solution like this. Since it's multiple choice, we'll pick the one that's closest to it. $4.40 is between $4 and $6, but it's closer to $4 than it is to $6. So we'll stop here for this video, and we'll move on to some practice next. Bye.